Okay, the next topic under trigonometry that we're going to be looking at is how to evaluate the area of a triangle when you can't use the traditional base times height method. Looking at this slide, you can see that you can calculate the area of ABC using these three equations. They pretty much all mean the same thing, but they're just configured differently in case you needed help looking at it. So it's 1/2 AB times sine of C, 1/2 AC times sine of B, or 1/2 BC times sine of A. And depending on what combination of values you have, you can use one of these equations to determine what the area of your specific triangle is. Now, it will make more sense with an example. So looking at the question, if a triangle ABC has the A side of 8 centimeters, the B side of 10 centimeters, and an angle C of 60 degrees, what is the area going to be? It's pretty simple. All you have to do is plug in the numbers into the right equation, which in this case would be the equation 1, because we have AB and the angle C. And then by doing the math for this, we'll see that the area is 20√3. What I like to do a lot of times is I like to break up these equations into two parts where I take this first and then sine after, just because it's a lot easier to use whole numbers on one side and then figure out sine by itself. So here what I did was I broke down 8 times 10 first, which gave me 80, and then I divided that by 2, which is 40. And then I went in to solve sine of 60 because that's its own problem. And using the unit circle, you would see that that is equal to √3/2. So then you have 40 times √3/2. When you cross everything out, that's going to give you 20√3, which would be the answer to our area for this specific question. Anyways, now that you have an example here, I'm going to provide some practice that you should do on your own. Here are the practice questions. They're an amalgamation of the last couple topics and area of triangles to provide some difference in difficulty with each question. On the next slide, as usual, I'm going to provide explanations of each question to help you familiarize yourself with these topics. So now to answer each of these, you really just should be using the equations I provided. They're fairly easy to remember because all you need is to remember one and all of the others follow the same pattern. So first, for question 1, I asked you to find the area of triangle ABC given that side B is 7 centimeters, side C is 8 centimeters, and the angle of A is 45 degrees. This is a fairly simple question, just like my example, where all you had to do was plug in the numbers into the equation. Using the equation, you would get 1/2 times 7 times 8, as you can see here, times sine of 45. And then I did the same thing where I broke it up into 7 times 8 is equal to 56 divided by 2, which would give you 28. And then I multiplied that by sine of 45 so I could have some algebra out of the way. And then once I figured out sine of 45, which would end up being √2/2, I multiplied 28 by √2/2, which would give me 14/2, and then that was my answer. So this question was simple enough, and I am not going to explain my algebra as much anymore because it's going to get more complex, and I want to look at the complex additions more closely than I do at the algebra. Okay, so for question 2, I asked a very similar thing that I did in question 1, but instead the angle was 150 degrees, which makes the conventional way of solving this a little bit harder. So to solve this, you have to recall back to obtuse trigonometric ratios and use the equation sine of 150 is equal to sine of 180 minus 150 to help you figure out what the answer to this question is going to be. So in doing this, you would find that sine of 150 is equal to sine of 30, which is equal to 1/2. So now that you have that 1/2 value, you can split the problem apart again as I did before, which would be 5 times 6 giving us 30, divided by 2, 15, and then times 1/2, which is going to give you 15/2, which is our answer. Finally, for question 3, I asked you to find the area of a triangle with the side lengths 12 and 15, where sine of C equals 1/2. This question might seem a little bit off because you don't have the degrees required to calculate this. However, if you look at the way the question is formatted, you will notice that sine of C appears in the equation as a whole, which allows you to replicate sine of C with 1/2, and you don't have to do any further math for this part of the question. You're basically just substituting 1/2 right in here, and you don't need the degrees for it. And then if you follow the multiplication conventions with the side lengths, you'll get an area for the triangle ABC as 45 centimeters. That's another thing. I haven't put my units on any of these, but you do need units on everything in math. So the area would be 45 centimeters. Now, all of these questions were very much in the realm of potential questions someone could ask you about the area of triangles, as none of them really require further thinking beyond simple topics. So I would be sure that you have this part of trigonometry down, as it's very foundational. Okay, just to recap, you can use these area equations to find the area of any triangle if you know the sides and an angle. Using this equation allows you to circumvent finding the height of a triangle, which is helpful for irregular shapes. And something that you will see throughout your studies in trigonometry is that sine values are essential, and you should do your best to learn them and understand how they work. Finally, to connect with finding the area of irregular triangles, I'm going to move on to sine and cosine laws, which also apply to most triangles, so kind of just expanding this theme of irregularity.